Hey everyone, in this video we are going to talk about ArcadeDrive, which is just a fancy way of controlling your existing tank drive base, alright? So think back to sort of the previous way that we controlled our tank drive, right? The idea was that each axis, the y-axis, right? Each joystick's y-axis independently controlled each side of your tank drive, right? So you move the left joysticks forward, then the left side of the drivetrain goes forward. You move it backward, and only the left side goes backward, right? Same idea with this right joystick, right? You move only the right one forward, the right side goes forward, and the same idea for backward for the right side, okay? But with ArcadeDrive, right, the main difference is that it's designed to be a little bit easier to maneuver, right? Especially for novice FRC drivers, right? So the idea is that one joystick will control the literal drivetrain's forward and backward movement, right? So it's going to control both the left and the right side simultaneously, okay? So the idea is that, right, once you move this left joystick forward, the entire drive base will move forward. And the same idea goes with backwards. And then this right joystick's x-axis, right, this other right joystick, right, it's going to be used for rotating the robot in place. So when you move it to the left, it'll rotate counterclockwise. When you move it to the right, it'll rotate clockwise, okay? And the main idea, right, is similar to that of moving a car, right? You can move the car forward and backward, you turn the wheel left or right, and then it turns, right? So it's a similar idea here. Okay, so now let's talk about coding this because it's not as straightforward as just writing a new command, all right? It involves a little bit of manipulation within the tank drive subsystem. So here's the tank drive subsystem, right? And the first thing, right, that you're going to want to do is make something called a differential drive object, okay? So we're going to declare our differential drive object. Okay. So in order to do that, it's just going to be private differential drive, and we're going to call this KDrive. Okay, we're just going to import this. Okay, now we're not going to actually initialize it here. You can if you want, but what you'll find is that you can't really properly initialize it quite yet without doing a lot of moving around. So instead, I prefer to declare it and then initialize it at the bottom of our constructor. Now the reason why we have to do it at the bottom of the constructor is because the differential drive constructor will take in your motor groups, all right? So it'll take in the primary motor of each side, okay? So it's going to be new differential drive, and then we're going to do left primary, and then we're going to do right primary. And that's it. That is all you need to do in terms of making it. Now, because we made it private, let's just add a quick getter method in order to actually use this in our command, all right? So let's do a method to get the differential drive command. So it's going to be public differential drive get KDrive, we'll call it. And we're just going to return KDrive. That's it. And we can add a quick Java doc. Let's do a method to get the differential drive object, and then we're going to return a differential drive object, which is going to be accessed by other commands. All right, so that's the main idea for the subsystem. Now let's go ahead and make a new command. All right, so this is going to be fairly straightforward. It's going to be very similar, in fact, to the tank drive command, but because we have this differential drive object doing a lot of the work for us, it's actually a little bit simpler. So we're going to go ahead and create a new class / command. We're going to call this, well, this is going to be a command. We'll call it ArcadeDrive command. Okay. And then the first thing that we're going to do, right, is declare our subsystem and then the suppliers, okay? Declare subsystem and controller suppliers. So we're going to do private tank drive subsystem, drive subsystem. We're going to do private double supplier. We're going to call this a translate supplier. And the reason why I call it translate is because, well, it's moving forward and backward, so it's translating. Okay, so that's the idea. And then we're going to have a rotation supplier. This is going to be the x-axis, all right? And this is going to be rotational supplier. Okay, so again, we're going to take all of these in so we can initialize them. So it's going to be tank drive subsystem, let's call this drive, and that's going to be double supplier, T supplier, let's call it, and then double supplier, we'll call this R supplier. Okay, Then it's going to be this dot drive subsystem equals drive, this dot translate supplier equals T supplier, this dot rotational supplier equals R supplier, and then we're going to add requirements for this dot drive subsystem. Okay, fairly straightforward stuff, right? Now, just like before, we're gonna use the deadband value of the controller just to make sure we don't get any erroneous input. So double translate percent deadbanded equals, let's use math-util from WPILib, dot apply deadband. The value is going to be translate supplier dot get us double, and the deadband, let's just use the same one we used before, 0.07. Okay, and then we're going to do double rotation percent deadbanded equals math-util dot apply deadband. It's going to be rotational supplier dot get us double, and then the deadband is going to be 0.07. Okay. So now the deadband's set up. Now it's just as easy as drive subsystem, right? We're going to use that KDrive object, and then we're going to do .ArcadeDrive. And this is it. That's literally it. VS Code auto-completed it for us. We pass in the translate percent, and then the rotation percent. And that is all that you need to do to set up your ArcadeDrive. So, in code, what you can do is instead of doing new tank drive command, you can just do new ArcadeDrive command. And then instead of passing in the write y, you're going to do get write x. Okay, and that is all you need to do in terms of setting up your ArcadeDrive and making your robot a lot easier to drive. One thing to note is that Sim's not super great with simulating this, so unfortunately we can't really show you the best way of going about simulating this. If you want, you can print out your joystick outputs, but that's not really going to help you with anything. That's not really good sim practice. So eventually, if you do get to the stage of testing this on a physical robot, feel free. All right, so that wraps up this video on ArcadeDrive. Okay, thank you so much for watching, and I look forward to seeing you in the next video.